we are studying signals and systems, and in previous lecture we have studied about the Fourier transform, the difference between Fourier series and Fourier transform, and why frequency spectrum, we can say magnitude spectrum of Fourier transform is continuous as compared to discrete spectrum of Fourier series, है ना। हमारा जो Fourier series का स्पेक्ट्रम है वो Cn वर्सेस ओमेगा जो कि डिस्क्रीट है, डिपेंड्स अपॉन द वैल्यू ऑफ n, और Fourier ट्रांसफॉर्म का जो स्पेक्ट्रम है वो है x ऑफ ओमेगा वर्सेस ओमेगा जो कि कंटिन्यूस है। ठीक है, अभी जो कॉन्सेप्ट है कि Fourier ट्रांसफॉर्म का कॉन्सेप्ट स्पेक्ट्रम जो है कंटिन्यूस है, वो क्यों है? ओके, ये हमें एग्जांपल समझने के बाद हमारा कॉन्सेप्ट और क्लियर हो जाएगा। So we have to find Fourier transform of x of t equal to e raised to minus at u of t. Plot magnitude and phase spectrum. Okay, so let us solve this example. So we have x of t is equal to e raised to minus at u of t, and we have relation, we have Fourier transform equation. So it is Fourier transform equation. Okay, and what is this Fourier transform? This is called continuous time Fourier transform, okay, where we use integration. So x of j omega or x of omega, ये जो notation है x of j omega, it tells that it is a complex valued function. Okay, for simplicity we are using x of omega. So it is integration over minus infinity to plus infinity x of t e raised to minus j omega t dt. Okay, so substitute x of t के प्लेस में हमें e raised to minus a t u of t पुट करना है. So we'll get x of omega is equal to integration, okay, and here it comes the x of t e raised to minus a t u of t, or already we have e raised to minus j omega t. Okay, now what is the presence of u of t? अब u of t present है, it means okay, it will change the limit, जो lower limit है ये change होगा because of presence of u of t. Okay, say u of t start, okay, we have u of t equal to 1 for t greater than 0 and 0 for t less than 0. Okay, so this is our u of t. This is u of t. If you multiply any signal using unit step function, so this process truncate the signal part for t less than 0. जो भी t less than 0 part है x of t का, वो क्या होगा, truncate हो जाएगा. The signal will start at t equal to 0. Therefore हमारा जो previous equation will become 0 to infinity e raised to minus a t. Now u of t is gone because we have taken 0 and its magnitude is 1. So it is e raised to minus j omega t dt. Fine. Now it will be 0 to infinity e raised to minus a plus j omega t dt. How we got this? By using this relation. So we have used e raised to a into e raised to b is equal to e raised to a plus b. Okay, so we have minus a and minus j omega t. If you multiply this, we'll get the same thing. Fine. Now let us find the integration of this. So it is e raised to minus a plus j omega t divided by minus a plus j omega, okay, not t. T will be here, and here it is 0 to infinity. Okay. Now how we got this integration? Okay, by using a relation, integration of e raised to ax dx. A formula is integration of such quantity is calculated by using this formula. So it is e raised to ax divided by a. So a जो वेरिएबल है x is the variable, integration with dx, and this is the coefficient of x, therefore it is the denominator. Okay. So let us substitute the limit in this example. We'll go to the next page. So it is x of omega is equal to, so first of all substitute upper limit, so it is e raised to minus a plus j omega infinity minus e raised to minus a plus j omega into 0 divided by minus a plus j omega. Okay. So limit कहाँ पर पुट करना है? t के प्लेस में. So here it is t and here it is t. Now e raised to minus infinity, okay, minus a plus j omega multiplied by infinity will become infinity. So it is e raised to minus infinity minus e raised to, it will be 0, okay, and it is minus a plus j omega. So this is our relation, and e raised to minus infinity equal to 0 because it is a very small quantity. Okay. So what we'll get? We'll get 0 minus 1. So e raised to 0 is equal to 1. So it is minus 1 divided by minus a plus j omega, and this is equal to 1 divided by a plus j omega. This is our x of omega. Okay. We'll go for the next page, and here finally we have calculated x of omega 1 divided by a plus j omega. So this is our Fourier transform of x of t. Okay, and this term contains real and imaginary part. Okay, to make it simple, okay, we can find, okay, first we'll find magnitude from this quantity. So it will be magnitude of this, magnitude of x of omega find करना है, and we have relation for this. क्या relation है हमारे पास? So magnitude of x of omega is denoted like this, and this is equal to, so this quantity, इसका जो real part है उसका square, and name of this quantity is x of omega. So real part of omega is xr of omega square plus imaginary part जो है ना इसका x of omega का उसका square हम लेंगे. So we got this. ठीक है. So what is the real part? Let us find numerator. So this quantity is numerator and this quantity is denominator. Okay. उसका हम magnitude find करेंगे. So what is magnitude of 1? So it is 1. And what is the magnitude of this quantity? Magnitude of a plus j omega. Okay. What is this? This is the real part and this is what? Imaginary part. जो j के साथ है, that is imaginary part. So magnitude will be what? So it is a square plus omega square. Simply. Okay. Substitute here. So we'll get magnitude of x of omega, which is equal to 1 over square root of a square plus omega square. So it will be x of omega is equal to 1 over a plus omega. So this is our magnitude of x of omega. Fine. From this we can find the magnitude spectrum. First of all, okay, we'll come back to this point. For phase, we'll come back to this, and from this first we'll find the magnitude spectrum. Okay. तो मैग्नीट्यूड स्पेक्ट्रम जो है, so it is graph magnitude spectrum. Okay, so it is graph plotted x of omega. Okay, not x of omega but magnitude of x of omega versus angular frequency omega. Okay, and what we have, we have magnitude of x of omega. See this, we have 1 over a plus omega, this quantity we have. Now let us take a equal to 0. What will happen? So x of omega, okay, we'll write different way. Okay, इसको हम different way से लिखेंगे. So value of a and value of omega and value of x of omega. So what happens? See, a equal to 0 लिया है हमने, so what will be this? Okay, or simply we can say, okay, a को हम 0 ही consider करेंगे. Okay, always a is 0. Okay, and omega equal to 0, it will be 0. Okay, but it is 0. Okay, and omega equal to something. Okay, when omega equal to a equal to 1, क्या होगा? When a equal to 1 and omega equal to 0, what will get? We'll get x of omega equal to 1 by a. We'll get this quantity. Okay, so let us plot the spectrum, the graph. This quantity we have, and it is 0, omega, minus omega, and magnitude of x of omega. Okay, so at first when a equal to 0, we are not getting anything, but when a equal to 1 and omega equal to 0, means there is no frequency. In this case, what will happen? We'll get 1 by a. This portion will get. Okay, it is the maximum height of the spectrum. Okay, now if it is 1 and we are changing the value of omega, imagine करो omega का value हम change कर रहे हैं. Okay, omega is 3 pi by 2, pi by 2, pi. Okay, minus 3 pi by 2. Okay, so pi minus pi, minus 3 pi by 2, 2 pi. Okay, what is the maximum range of this omega? Minus pi to pi in such cases. Okay, अगर right side को plot कर रहे तो 0 to 2 pi आपको लेना है. Okay, so what will happen? So it will change, it will change. If you change this value, this is constant. If you change this value, what will happen? So this x of omega will decrease. If you increase the value of omega, so this will decrease. So we'll get like this. So it is like this. If you take different values of omega, the plot will be like this, and it is from minus pi to plus pi. This is the magnitude spectrum. Now what we got from the magnitude spectrum? एक ही signal है जो exponential है ना? So we have this kind of signal. See this. We have this kind of signal. It is e raised to minus at. Okay, it is start at 0. ये signal में, okay, what is the frequency and what is its magnitude? Okay, कितना magnitude है frequency का and how it is changing with change in frequency. अगर हमें ये पता है, okay, when this signal is mixed with noise, we can understood what is the noise and what is the signal and which frequencies need to be blocked. We can decide by looking at the Fourier transform spectrum. Okay, a frequency spectrum of Fourier transform. Now what is the phase of this? To find the phase, let us pick this equation, है ना, a plus j omega, 1 divided by a plus j omega. इसको हम simplify करेंगे and we'll find the phase. Okay, so it is x of omega we have, x of omega we have, so it is 1 over 1 plus j omega. Okay, इसका जो complex conjugate है वो है a minus j omega, है ना, एक है ना ऊपर के साइड में एक नीचे के साइड में. Okay, जो हमारा complex plane है. So if you multiply this using its complex conjugate a minus j omega, so it is a minus j omega. So this will become, so it is a minus j omega divided by a square, okay, so minus j square, so it is a square minus j square into omega square, okay, and we have the value j square is equal to minus 1, j square equal to minus 1, so it will become a minus j, okay, it will become a minus j omega, so it is a square plus omega square, so it will be a divided by a plus a square plus omega square minus omega, so it is j divided by a square plus omega square. So what is the real and imaginary part here? We can see clearly, ये जो part है ये है real part, so it is xr of omega, okay, and this part which is with j is xi of omega, okay, imaginary part है. Now we can find the phase from this. हमारा जो फार्मूला है फेज का उसको हम यूज करेंगे and we'll find phase of this, okay. What is the phase of this? Phase angle of this is angle of x of omega is tan inverse of imaginary part of omega divided by real part of omega, okay. So what we'll get? We'll get tan inverse of जो imaginary part है हमारा वो है omega divided by a square plus omega square, and it is other quantity is a divided by a square plus omega square, okay. So what will happen? So this will, okay, cancel, and what is remaining is, actually it is minus, if you see carefully, so this portion is minus this one, okay. So take minus omega, okay, so we'll get minus tan inverse of minus omega by a, so this is the phase, so it is equal to minus tan inverse of omega divided by a, okay, by using tan minus theta equal to minus tan theta, ये हमारे पास फार्मूला है ट्रिग्नोमेट्री का, इसको हमने यूज करके we have minus tan inverse of omega by a. Now this is the angle of x of omega, मतलब जो फ्रीक्वेंसी कंपोनेंट प्रेजेंट है वो सिग्नल के रिप्रेजेंटेशन में, उस सिग्नल के डिफरेंट जो फ्रीक्वेंसीज है, ओके, तो उसमें व्हाट इज द फेज डिफरेंस बिटवीन दोज फ्रीक्वेंसी कंपोनेंट प्रेजेंट इन द रिप्रेजेंटेशन ऑफ दैट सिग्नल, ओके, उसको हमें प्लॉट करना है. सो फ्रीक्वेंसी स्पेक्ट्रम हम प्लॉट कर सकते हैं. सो नाउ हियर सी a इक्वल टू 0 लिया हमने, तो क्या होगा? ओके, लेट अस टेक a इक्वल टू 0. आई विल रिमूव दिस. a इक्वल टू 0 लेंगे. ओके, टेक a equal to 0. So what will be angle of x of omega? So it is minus tan inverse of omega divided by 0, है ना? So it will be infinity. So it is infinity. So it is tan inverse of infinity. This is equal to minus tan inverse of infinity. So it is tan inverse of infinity क्या है? It is pi by 2. So it is minus pi by 2. Okay, and if you take minus omega, okay, for this is for plus omega, and omega is minus, omega is negative. जो लेफ्ट साइड का है हमारा स्पेक्ट्रम का, उसमें क्या है? ओमेगा निगेटिव है. ठीक है, तो क्या होगा? So it is angle of x of omega is equal to minus tan inverse of minus infinity आएगा. So it will be plus pi by 2. Okay, now let us plot the phase spectrum of this. Phase spectrum we have this. This is omega and angle of x of omega. again, and it is minus angle, and this is what? Minus omega. So what will be this spectrum? क्या होगा? So let us take plus pi by 2 here and minus pi by 2 here. ठीक है? So what will happen? So it is minus pi by 2. If you change the value of omega, okay, this is negative values, and this will start decreasing from this. See this approximately, and it will fall down. जैसे आप ओमेगा के वैल्यू है ना, ये व्हाट इज दिस हायर वैल्यू 0, ओके, पाई बाय 2, 3 पाई बाय 2 एंड 2 पाई, दीज आर द वैल्यूज. तो इसको हमारे जो वैल्यूज मिलेंगे इसके, it will be like this, it will start decreasing, and here this side it will be this one, okay, this is plus and this is minus pi by 2, and this is what? Antisymmetry. This is the phase spectrum. okay, फ्रीक्वेंसी कंपोनेंट जो प्रेजेंट है रिप्रेजेंटेशन में, इसके बिटवीन क्या फेज है हमें इस स्पेक्ट्रम से पता चलेगा. ओके, सो नेक्स्ट क्लास विल सॉल्व वन मोर एग्जांपल ऑफ फूरियर ट्रांसफॉर्म.